This dot is a position, but this arrow is something different. It tells the dot how to move. That is the first idea of linear algebra. A vector is not where you are, it is how you move. Now move the same arrow somewhere else. The starting point changed, but the movement did not. Same length, same direction, same vector. When we finally draw a grid, the arrow can be translated into numbers. This movement goes 3 steps across and 2 steps up. So the vector becomes 3 over 2. But the numbers are not the vector itself. They are a recipe for the movement. Every vector has 2 visible features. Its length tells you how much movement happens, that is, its magnitude. Its angle tells you where the movement points, that is, its direction. For a vector with components x and y, the length comes from this right triangle. Vectors can also be added, but addition does not mean stacking symbols. It means doing one movement, then another. First move by v. Then from the new place move by w. The total movement is the single arrow from the original start to the final end. A number in front of a vector changes the amount of movement. 2 times v moves twice as far. Half of v moves half as far. A negative number reverses the direction. And 0 shows the movement completely. Sometimes we only want the direction, so we divide a vector by its own length. The result points the same way, but its length becomes 1. So a vector is movement. Components are its recipe, and operations change the movement. But one question is still hiding. Who chose the grid? This is the hidden dimension. See beyond the symbols. Discover the ideas.